Today we're going to answer three big questions. What do hail clouds look like? How do hail clouds form? And why is it more likely to hail in the summer? Let's start with what hail clouds look like. This is a hail cloud. It's easier to notice what's different about a hail cloud if you compare it to other types of clouds. You probably noticed that hail clouds are very tall and also very high. What do we know about the temperature of the air at different heights? We know that air is colder when it's higher. How might the air temperature at different heights be related to the formation of hail? You might be thinking that hail is frozen water, so it has to be very cold in order to be formed. Now that we've answered what do hail clouds look like, let's think about how hail clouds form or are made. Here's a video that shows many different clouds forming over the course of one day, so it's super fast forwarded. At the end of this video, you're going to see a hail cloud. Right now, we're just seeing normal clouds. You might be noticing that they're not going very high. Now we're going to see a hail cloud form. Notice what happens here. You're probably noticing it's going up. Eventually it stops going up. And some of it even starts to go down again. We saw that the cloud went up, higher and higher and higher. Eventually the air stopped rising, and at the end, some of the air even went down again. Why is the air moving up, stopping, and then moving down? It has to do with density. Last week, we talked about density means particles are very close together. When particles are very close together, they are more dense. And when particles are... Last week, we talked about density. It's how far apart particles are from each other. Particles that are closer together are more dense, and particles that are farther apart are less dense. In the models you made, you showed you understand that air closer to the ground is more dense, and air higher in the sky is less dense. When the sun heats up air near the ground, it gets hot. We know that hotter particles spread apart and start to move faster. In general, nature likes to equal out, so you'll notice that these densities are not the same. So what happens is that the air is going to rise, and it's going to transfer out energy as it rises until it's the same density and the same temperature as the air around it. As it rises, it lets go of energy. Just like we learned about last week, when the particles hit other particles in the surrounding air, they transfer some of their thermal energy. Let's review. Air near the surface of the ground is warmed from thermal energy transfer from the ground through a process called conduction. The warm air near the ground becomes less dense than the surrounding air, and it rises. Eventually, the warm air transfers its energy to the surrounding air, becoming just as cold and dense as the air around it, and then it stops rising. It does not stop until it's the same temperature and the same density as the air around it. If that air becomes even cooler than the surrounding air, it sinks. This type of air movement happens more on sunny days because the air right above the ground gets warmed up more by light from the sun on those days. Because it got warmed up more, it has to move even higher to transfer its energy out and become the same temperature and density. Once it gets high enough, it's cold enough to form hail. We've answered the question, what do hail clouds look like? They're tall and high in the air. We've answered the question, how do hail clouds form? It has to do with the air rising until it's the same density and temperature as the air around it. We also know why it's more likely to hail in the summer, because there's more sun, and so the air near the ground gets heated up even more.